Hello, this is Mr. Deng and welcome to the AB Calculus. All right, let's pick up from our last class, and that is 5.3. We are dealing with inverse function. Okay, and this is the formula to find the inverse function right here. Let me review with you. Let's say the function f of x. The function f of x, if we say that the inverse of f of x, let's say if g of x is the inverse of f of x, then when you take derivative of the inverse, this is how you get the formula. And I proved to you already by just one line. Let's do it again, okay? By definition, if g of x is the inverse of f of x, then by definition, you will have the composite form of f of g of x, okay? Equals x. There we go. And that is the definition. Now, I am proving, looking for the derivative of the inverse, okay? Noticing g of x is the inverse, okay? And that's how you say it right here. There we go. But we try not to use this form because it might be confusing with 1 over x. Therefore, g of x is the inverse, okay? Now, let me prove to you, how do I find the inverse? How do we find the derivative of the inverse? This is the definition. I'm going to take derivative both sides, okay? So here's how we have. Take derivative both sides. There we go, okay? Take derivative both sides here, and that will give you, this is a composite function. So you have f prime of g of x. There we go. And since there's another layer right here. Remember the Shrek thing? Okay, so you have to time with what is inside of that function. There we go. That's the chain rule. Okay, guys? There we go. All right. The derivative of x on the right side right here, okay, that is 1. Everybody sees that? Here you go. Take derivative both sides. The function itself is right here. And the layer, the chain rule of g prime of x. There we go. And then derivative of x is 1 itself. Now, I am looking for the derivative of the inverse. So I leave this one right here, and I divide both sides by whatever this. There we go. Okay, same thing with that. I do it over here because the purpose is looking for the inverse, the derivative of the inverse. There we go. By that, this is all gone. And this is my form right there. G prime of x, which is the derivative of the inverse of the function, equals 1 over the derivative of the composite function. All right, we did that together in class. I just want to remind you. Now, one thing that we talk about the existence of an inverse function when the function has an inverse, meaning that function passes the horizontal test. Okay, so let me review with you so that you see. So let's say y equals x squared. Okay. To make this function have an inverse, you have to set the condition for x, okay? Meaning, in the case that x bigger than or equals 0, then you will have the function, the graph of this guy will look like this right here. There we go. Noticing I set condition, okay? So that it passed the horizontal line, okay? Now, I want to find the inverse of this guy. Okay, solving for x to find the inverse, which is in this case right now you have y equals x squared. Solving for x, you take square root both sides. I'm going a little fast because we did this already. So now you have this, meaning the square root of y equals x, okay? And you take the positive side over here. So this guy right here, you have the inverse. Put them back in the form of a function, meaning y equals square root of x, okay? This is the inverse of this function right here. Y equals square root of x equals y equals x squared. This is the inverse of that. To graph this guy, to make a point. To graph this guy right here, you see this one will go. There we go. Okay. My point is right here to see the graphs of the function and its inverse. They both are symmetric over the line y equals x. That is my point I'm trying to make for you, to just bring to your memory that the function and its inverse, the graphs of them both are symmetric over the line y equals x. What does that mean? It means that you look right here with me in your textbook and you will see the properties of the function and its inverse. To see that the function in that domain, if it is increasing, then the inverse is also increasing in that domain. Okay, this should go up a little bit so you can see. There we go. There we go. Okay, so if the function increases in that domain, then the inverse also increases. If the function decreases, then the inverse also decreases. Okay, and if the function is differentiable, then the inverse is also differentiable, except one thing, and that is it cannot have the zero in denominator. Okay, except that when you do the inverse, make sure that the denominator cannot be zero. That's the only exception that we have here. Okay, the application, I'm going to erase the board so we can do some application. 5.3, even though we already finished 5.3, but let me just do homework with you, and I set you up for your homework as well. Okay, what is the application of the inverse function, guys? We talked about this in class, and that is one of the huge application of the inverse function is to convert units, and to convert when you travel overseas, you convert currency. Okay, one of the great examples that you have learned in physics, and I believe in other classes as well, and that is the converting of the Fahrenheit into Celsius and vice versa. I am picking up your homework. Okay, I post homework on 5.3. I'm going to do number 40 with you. Okay, shall we? Let's do number 40 so you can see the beauty of inverse function. Turn your textbook with me to number 40. Okay, all right, I catch your attention because I'm doing your homework with you. So here we go. Number 40. You have the formula, a very famous, popular formula, and that is right now you have Celsius is being expressed in the form of Fahrenheit degree, and that is F minus 32. There we go. In this function, you can imagine this is y equals 5/9 times x minus 32. X and y, now you put into the application. C is the Celsius degree, and the F here is the Fahrenheit degree. Now, in the condition over here, the textbook gave us, which is very appropriate, F must be bigger than or equal negative 459.6. What does that mean? Well, it means that, you know, in nature, your Fahrenheit cannot drop lower than this, because that zone right there, so far, it's really, really hard to get, if not, does not exist so far in our real world. So we have to set the degree of Fahrenheit, cannot, you know, go beyond that, because we cannot get to that degree. Okay, so how do I do this problem? Let's do number A, okay? Letter A. Find the inversion function of C. Okay, here we go. Y equals 5/9, x minus 32. Find the inverse function. How do we do that? Guys, we know how to solve for inverse function, right? Solving for f. There we go. This is one step right here. Solving for f, you just really time both sides with 5/9. Then you will have over here f minus 32 equals what? C times with what? 9/5. Well, normally I put the constant first, but just since I do on the board, I do that so you can see. So now solving this one right here, bring 32 over, you have right now f equals what? F equals 32 at what? 9 over 5c. Okay, there we go. Ladies and gentlemen, this is f now being expressed in terms of c. B. Okay, I'm looking at B. What does the inverse function represent? Yeah, what does this represent? This is the inverse function of C. The inverse function gives the Fahrenheit degree corresponding to the Celsius temperature C. Okay, I repeat, the solution, the answer for B. What does this mean? It means that the inverse function gives the Fahrenheit degree corresponding to the Celsius temperature C. And that's all. Let's do C. I know I'll go a little fast because I'm reviewing, and you can pause the video anytime to digest if you, just in case, don't get it. Let's do letter C. Letter C asks us, what is the domain of the inverse function? There we go. What is the domain of the inverse function? Noticing that f cannot get below negative 5.9.6. Therefore, to find the domain of C, you just simply plug the value in for f. Here we go. Plug the value in for f, which is negative 5.6 equals 32 plus 9 over 5c. Solving this for c, bring 32 over. Overall, you will have c equals, and I will just give you the value right away, and that is negative 273.1, and repeating of that. So now they ask for the domain, which means f cannot get lower than this, which is f must be bigger than or equal to this, so you can have a real temperature. Meaning at the same thing, C must be bigger than or equal negative 273.1. Repeating. Okay, there we go. And that is A, B, and C. On part D, okay? On part D. I'm not going so fast here, am I? On part D, they ask, what if C is 22? Because I know I'm insulting your intelligence right here. If C is 22, what is Fahrenheit? Typically, can we do the math right here? We just plug in the value. We have F equals 32 plus 9 over 5. And C right here is what? 22. There we go. You do the math and you get 71.6 Fahrenheit. I mean, take this out right there. Okay, I got you number 40, and I want you to see the application of the conversion and what does it mean when to find the domain. Just want to explain this one more time. The reason we set the domain for F is because Fahrenheit cannot go below this one. Same thing. When you plug it in, you will see another domain for the value of the Celsius degree. Okay, I'm looking at the example right here, and let's do, I put on 72 and 86. I have your homework posted on RanWeb for you, okay? So let me do similar problems and set you up for your homework. And already we conclude 5.3 in a very short video, so we can move into 5.4. Okay, you're ready? I am flipping to page 350, okay? 350. All right, and let's look at number 77. Okay, all right, here we go. We did this, several of these problems in class, but I know over a long break, you might have forgotten. Boy, that's scary. Number 77, here we go. All right, number 77 on page 350, okay? Page 350. The text asks us to verify that f has an inverse, then use the function f and give real number a, okay? And find the inverse of a. Let's go. Number 77 is a pretty cool problem. I picked that one because it is a little long. here we go. X minus 2, and now x bigger than 2. All right, you will see why we have that. And a here is 3. All right, let's divide the board into right here. Okay, let's look at 72 with me right here. All right, here we go. First of all, the textbook asks us to verify that this guy has an inverse. How do you verify a rational function has an inverse? And the technique to do so is to, take derivative of the function f of x. Okay, all right, here we go. This is one stone that kills several birds because I am now reviewing with you to take derivative of a rational function. So what would the derivative of this function looks like? Remember, u over v, guys? U over v, okay? U over v equals u prime times v minus v prime times u over v squared. Over here, you have that right there. Your u is x plus 6. That's your u. Your v is x minus 2. All right, shall we plug in? F prime of x right here. Here we go. U is, you said 1. There we go. And your v is x minus 2. Beautiful. Minus, your v is just 1 again. And x plus 6. There we go. Over v squared. X minus 2 squared. There we go. Now, work this out. Simplify the numerator. You see right away, x minus x, that's 0. Negative 2, and you distributive negative into positive 6, you got negative 6. So you got negative 8 over x minus 2 to the square. Okay, you ask, Mr. Deng, where did the x go? They cancel out. Look right here, because of the limited space. I hope you see this. I believe you see that, okay? X minus x, the x is cancel out when you take off the parentheses, okay? Factor it out, you will see it. In this case right here, ladies and gentlemen, tell me, the f prime has this value right here, and your denominator is always positive because it's squared. Therefore, the sign of this derivative depends on negative 8, and this is constantly less than 0. Now, what have we learned? If the derivative is constantly decreasing or increasing, then the function is monotonic. If the function is monotonic, it passes the horizontal test to have an inverse function. So what we say right here is, since the derivative is a monotonic function, okay, therefore it has an inverse. There we go. Your next thing is, well, then what is that inverse? Happily, we are not asked to find the inverse, but we are asked to find, so what is the derivative of that inverse when the value of a right here they gave us is 3. What would that look like? Okay, there we go. They gave us a is 3. So what is the derivative of the inverse when its inverse has the value of, let's say the x of the inverse is 3, and here you have, there we go, g of 3. That's our battle right here, ladies and gentlemen. All right, so here we have. Let's go into the function and to find that, okay, in the real value of the function, in the function right here, you have, let's say, if a is, let's say, if a is, what is the value for x? That you have a is 3. This is for the function f of x. Okay, you see it, guys? Here you go. Use different colors so you all can see this. All right. They gave us this one right here, which means, okay, which means that what is the value for x? Okay, here's the function. X plus 6 over x minus 2. There we go. They gave us a, and a is right here. Okay, there we go. A is right here. There we go. what is the value for x? That once you plug in, you got 3. That's your A. Okay, there we go. This is A right here. There we go. That's your A. So your job right now is to find the value for x. Okay, so that you can go ahead and find the inverse as well. Remember, the input and the output, they change when you move from a function to its inverse. Let's go. You set the function equals A. All right, what's A? A is 3. So here we go. Okay, let me erase the board over here so you all can see this. You know what? Because we're going to use this in a little while. Here you go. Let's see if I can do this. Here we go. A is what? A is 3. Equals x plus 6 over x minus 2. There we go. What am I looking for? I'm looking for, Mr. Jang, what is g of 3? Okay, in a moment you will see this. Solve this one for me. Can I time both sides with x minus 2? Okay, time both sides with x minus 2. So this will have x minus 2. There we go. And this time with that, you got that one out. There we go. Can I do that, guys? So here we go. Distributive this in for me, please. 3 times x is what? 3x. 3 times negative 2 is negative 6. There we go. X plus 6. We almost home. You see right here, can I solve this for x? Can I bring x over here? There we go. So then you got minus both sides, you got 2x. And bring negative 6 over here. And the technique of that is add 6, you got 12. So there we go. X equals what, guys? 6. Bingo. Bingo. In the function, you now know, okay? You now know the function right now has a value of, this is your x, okay? 6. So there we go. In the function, it is what? It is 6, 3. That's the function f of x. Can anyone tell me if this is the input 6 and the output is 3 for the function, what is the inverse of the function would look like? Correct. You switch the output and the input together, you will have what? If 6, 3, then you get what? 3, 6. Perfect. Perfect. You see it? That's why we are going for, we've been working this one out so that we can find what is the inverse, what is the derivative of the inverse of g of 3. All right. Now, let's move into our solution for part B. Okay, here we go. Now that you have, I'm going to erase this for you. Okay, here you go. There we go. Okay, here we go. You now looking for the inverse, the derivative of the inverse of g of 3. G inverse of 3. Okay, so we got 3 right here. 1 over f prime. But then you see, what is g of 3, guys? The inverse is what? 3, 6. There we go. What is g of 3? Correct. 6. That's why I got 6 right here. Okay, careful. Look. This is a key move right here. G of 3 is right here. This is the function inverse. Okay, when x is 3, you got g of 3 is 6. That's why you got 6 right there. Now that's a little bit less, intimidating than in this form right here, because I just work out that for you. All you do right now is to take derivative of the function, which you already have, and I did not erase that for a purpose. You know f prime is right here. F prime is right here. You see that, guys? F prime is right here. All you do right now is just to plug 6 into the function. See? So f prime of 6, all you do right now is just to plug 6 into this guy. Okay, got it? Plug it in. Negative 8 over 6 minus 2 square. So you got negative 8 over, which is the bottom one, will be 4. 4 squared is 16, and that gives you negative 1, 8. Right there. Okay, you have down here is negative 1 over 8. Can I plug it in for you? I got the board right here. There we go. That is negative 1/8. 1 over negative 1 over 8, which is what? That's right. Flip that, you will get negative 8. Ta-da! Okay, beautiful. Now, this is what the textbook wants us to do on part B, and that is finding the derivative of the inverse with specific value is given. Noticing how you know your work is correct. Can anyone tell me, Mr. Deng, how do I check that my derivative of the inverse is correct? Look at this. They are reciprocal of one another. You see that? The derivative of the inverse is negative 8. What is the derivative of the function itself? You see right here? Sorry, the inverse derivative is negative 8. The derivative of the function itself is the reciprocal of that value, which is negative 1 over 8. By that, you have a big check right there, guys. Okay, pause the video, prepare questions. If you have any questions for me, I will answer you. Email me or we will see each other soon through Zoom meeting. Okay, I'm gonna tackle another example for you, and that is example 86, okay? Let's do 86 so that you will see. Let's see, 86 over here. There we go. We're looking at a good, great review of the implicit differentiation and the application to find the linear function, which is the tangent line to that. I'm doing a few problems to get you warmed up to inverse function before I jump into 5.4. Okay, guys? All right, would you look at number 86, which is also a similar problem to your homework as well. Okay, I'll put that there for you as a good thing to memorize. 86. All right, here we go. Number 86. What does it ask? What does it require us to do? Let's see. 86 right here says find dy over dx, which is, for the equation given. All right, here we go. Number 86. You have x, okay, x equals 2 ln y squared minus 3, and the point given, perfect. And we are asked to find the derivative of the function for the equation at the given point. Okay, so technically find what is dy over dx. You're ready? Okay, which is they provide us a specific point. Therefore, your outcome, your answer should be a value of real value. Okay, but before that, you gotta find what is dy over dx. Shall we? Okay, to find dy dx, go ahead. We do the explicit, which is take derivative of both sides. Okay, that's it. All right. I am going step 1. Step 1. Take derivative, okay, of both sides. Derivative both sides. Okay. So what is derivative of x? That's right, 1. Now, come to this. Here we go. We know, y'all, we know. Let me remind you that ln of u derivative equals what? U prime over, correct. Very good. And u, of course, you cannot be, 1 bigger than 1. Okay. All right. We can go in there a little while. Okay. So here we go. Here we go. All right. Let's do this. It's a constant. Leave it out there. This is ln of the whole thing. Y'all look careful. The whole thing right here is u, okay? That's it right there. So u prime over u. Talk to me. Again, careful. This is the implicit. Implicit, which means that since you cannot express y in its own exclusive therefore exclusively, therefore you have to take it raw. Remember guys, take it raw. So u prime, what is the derivative of y squared minus 3? Very good. 2y. What else? Come on, we know that y is also another function of x, therefore we do the implicit form. There we go. This is equivalent to y prime. Just reduce the space. Okay, guys? All notations are equivalent at this point. Here we go. Okay, that's your u prime over what? Over u, which is y squared minus 3. Perfect. Okay, guys, back to business. What are we looking for? We're looking for y prime. That's it. What I don't have, what I do right now is just simply single y prime out by bringing everything on the other side. Okay? First, you can do this, all right? Take care of this. Can I divide both sides by 2? Yep. Divide both sides by 2. Both sides by 2. That's gone. Got it? And then, can I just simply time this y squared minus 3 both sides? Okay, let's do it. Y squared minus 3 both sides. There we go. So this one, y squared minus 3 both sides, and that's gone too. So far, we are using math principles to do same thing to both perfect balance equation. Nothing changes, but that helps me to solve for what I am looking for. Again, this is how mathematicians, scientists, and physicists, they develop and they write their equations, solving for a specific variable. Here we go. I'm looking for y prime. So what do I do with 2y? Correct. Who said that? Good. 2y over 2y right there. Boom. You guys get what you want. Okay. Now, the next thing you say, oh, Mr. Dan, it looks complicated. Don't let that bother you. We're just simply looking for what? We're looking for a specific constant, a specific value of dy over dx. Now you got what you want. What on earth? Now we go. Well, simply plug in the value, shall we? Okay, this is your value right here. They want to know specific at that point 0, 2. What is the derivative of that looks like? Okay, of that looks like. That's like this is x, this is y. So over here, do you have x? No, even better. Even good if you have x because x is 0. So you have only y. Yeah, y is 2. Plug 2 in. What you have? Okay, can I bring it up here for you? Okay, all right, you have y prime equals, all right, here we go. Ready? 2, and y is 2, that's 4. 2 squared, that's 4, okay? Minus 3, there we go, time 1/2. All right, this divided by, what is it? 2 times 2, which is 4. Okay, so here we go. Here we go. What do we have here? We have right here is 4 minus 3. Sorry, that's 1/2. Okay, 1/2, and the whole thing divided by 4, which is 1/8. Ladies and gentlemen, the task is done. All right, there we go. So I will stop here for your first video as a review for 5.3 inverse function and the meaning, the application, and also the review of explicit differentiation and how to find its particular value for the derivative at that point. All right, until next video for 5.4, guys.